Hey everyone, my name is Seve, and this is the Electronics.dev podcast. We're going to be talking about the future of electronics with code. Um, but before that, Matt, how's your day going?
My day's going fantastically, thank you. It's a beautiful day here in San
It's
Francisco.
a little warm.
It's a depends who you talk to. I'm Australian, and so come popping over here. It's a lovely
Where are you
temperature.
from in Australia?
Melbourne, down south.
Melbourne. Okay. So what is the temperature range there?
Honestly, it's pretty similar to San Francisco. It's a
Really?
bit more varied. In the
Hmm.
middle of summer, it's pretty hot, and then in the middle of winter, it's a bit more dreary and rainy. But it's not quite like South Bay as you kind of imagine, beaches and all. But it's a beautiful place to be. But I'm not shy from a bit of heat here and there.
Very interesting. And first question, have you ever done a podcast before?
No, I mean the closest I've done is sort of how-to tutorial, that type of stuff with Datapile on like
Oh, interesting.
yeah.
Okay, fair enough. I did a little bit of I I was on a friend's podcast once, but I feel like the only thing I did was I went on Clubhouse. Did you ever go on Clubhouse
No.
when that
What
was the thing?
what is Clubhouse?
Clubhouse was like I don't even know how to describe it. You join a clubhouse and then people are talking and you can just kind of talk. So it's like being inside of a clubhouse where you can just chat with people. But if you're in a big room, it's kind of like doing a podcast. You have a couple people kind of running the conversation
Yeah.
and then maybe other people jump in and participate.
So it's kind of like Discordy type vibes with the mics on.
Discordy like vibes with mics on. But there's this one disconcerting thing about Clubhouse is that you can kind of see the audience when you're in the room. And if you start to go on some weird rant, you're
Yeah.
gonna see people drop out.
Oh yeah.
It's like having a live audience.
It's like having a Zoom meeting where not everyone is actually required to come, and you're
Right.
presenting your PowerPoint, and people are like, "Wow, this is a PowerPoint." Should we talk a little about ourselves first as well?
Yeah, let's do it. Well, I guess I can start it off.
Yeah.
Uh, my name's Seve. I'm working on TS Circuit, which is React for electronics. Basically, trying to make it so that web developers have an easier time creating electronics using those native technologies they're so used to with TypeScript and React. Um, Before this, I did a bunch of startups uh, in San Francisco and Boston.
Boston.
Fast.
Yeah. My name is Matt. Before starting Adapile, which again is a tool to design circuit boards with code, I was at Tesla for about 2.5 years, working primarily on the Megapacks, the big shipping container sized batteries, some of the thermal controls firmware, the test suite for all of those when you plonk them down in a pack, go knock out some coal power plants as well, which was pretty fantastic. And then prior to that, I was actually a mechie.
Oh, really?
Yeah, I was a mechanical engineer at a company called Lilium
Hmm.
in Munich, or just outside it. Really, they sell it as being in Munich, but it's nearby. Um, Loved living in Germany, Australian originally, mechatronics, robotics, and computer science by training. Basically, I love to make
That's
things.
all over the place.
Yeah,
When you were
really.
at Tesla, did you find yourself mostly in in code or mostly kind of in sort of your conventional electronic design tools?
No, I was mostly in code. I mean,
Mostly
I
in
was I
code.
was working as a software firmware engineer primarily.
Gotcha.
And so even typically when I wanted to bring up something like a system diagram, schematic, whatever, to work out what my firmware was supposed to do, I was kind of stuck with PDFs
Oh,
mostly.
really?
Yeah. And you kind of pulling those out of maybe even something like Confluence. Like if someone has attached them there, it was like the typical source of a PDF.
Oh, very interesting. So there's almost like this layer between the hardware team and the coding team of PDFs and wikis.
Exactly. And a huge part of that just came down to LTM licenses.
Hmm.
You know,
Oh,
yeah. And plus, actually, a riff that you don't notice either is pretty much almost all mechanical CAD and ECAD is Windows only. And
yeah.
there's a little bit of it that works on OS X, or you're running parallels,
Right.
which kind of sucks.
Yeah.
And so it's just these extra burdensome steps. And so, no, typically we'd deal with a PDF, some sort of semi-released artifact that you would typically get sent, as I said, either via Confluence, and just sort of hope and pray on. You write something, you work it up on your bench, and any rework notes on top of it that might have impacted how your thing actually had to function.
That's so interesting. So because of the limited Altium seats, there was kind of communication breakdowns or at least difficulties. And then that operating system thing you mentioned is pretty interesting. So what's your preference on
Oh,
operating system?
look, I'd never actually owned a Mac before I
Mhm.
moved to Tesla, or used one because I was cheap and I didn't want to buy one. And you do not get paid the same as you do in the States and the rest of the world. And so I decided to go for it, and I loved it. Haven't looked back since. So it's definitely the way to go
Big
as
Mac
well.
fan. I do have to say, I was a big ThinkPad person,
Oh
and
yeah,
then the M1 came out,
yeah.
and I tried that, and it feels like there's no going back.
Oh, it slaps. It's so good.
It's so good. It's so fast. It's just like a pleasure to use.
Oh, absolutely.
Yeah.
And it's funny as well because I'll be around a bunch of mates with like multiple monitors, etc. Personally, I like just sitting down with just my laptop,
Yep.
nothing but that in front of me, and go for it. And sometimes you need a charger because the thing only lasts 2 days.
Right. Yeah. Only 3 days. Yep. Yep. Exactly. Yeah. I think my ThinkPads, especially because I would always flash them with Linux or something like that, would only last like 4 hours.
Oh
You
yeah.
know, towards the end of their lives.
Oh,
But
thank God the battery is replaceable. You can carry three with you and switch
that's
them out.
true. That's true. Yeah. Yeah. I mean, you also, as it degrades, ThinkPads have this little red nub, and
Okay. Yep.
ThinkPad people love the nub. But
That's what you get one for.
that's right, exactly. You can't live without it. But after a while, trackpads are nice. They work.
Yep. I remember actually the ThinkPad nub that's been around long enough that I would have been 10. And dad was always in IT, and he brought home an old laptop they were going to throw in the bin. And I remember making a little joystick attachment for that nub so I could play
Mm,
Flight Simulator with like a little kind of joystick feeling on the computer. I thought it was the coolest thing. I would have been like 10 years old.
that's interesting. Here's an interesting question. I don't know how deep we want to get into our backgrounds, but when did you like start engineering? When did it all begin? My parents were also in IT. That's what kind of triggered the thought.
Cool. Yeah. I don't remember the start of it. There's a lot of photos of me as a tiny little kid, 3, 4 years old with cardboard and tape, building everything to my imagination. I did get a lawnmower for my seventh Christmas, I think it was, that I needed a bit of restoration to make the engine run again, but I wanted to build a go-kart. And so that was tear the thing apart, um, make it run again, which took a little while as a 7-year-old with a bit of help from dad. But clean out the carbs, get it running, and then assemble a little go-kart out of it. So it's been
Wow.
lifelong.
And this would have been gas powered, I assume.
Oh yeah.
Oh my gosh. What a hazard. But
Yeah.
go-karts are so fun. That must have been awesome when that was done.
Oh yeah. Incredible. There's the
Do you
stuff.
take that off ramps?
No, absolutely not. More of a backyard feature.
I see, I see.
But the stuff. You look back at it and you're right. Wildly dangerous stuff for a kid to do. But boy, it definitely kicked off my engineering career.
Yeah, yeah, for sure, for sure. I think I was making Flash games back in when Flash games were huge. Uh,
Yeah.
and yeah, somebody had like pirated, I forget what it was called. It was like before Adobe Flash, Macromedia Flash.
Oh yeah.
Someone had pirated it, and so I had that thing to use, and you could like make little animations or little games. And so I just spent all day trying to make games, copy and pasting code
Yeah.
snippets. Um, yeah, a little bit unconventional way to learn copy and paste. Maybe a lot of people do that. Just copy and paste, see how it goes.
Yeah, no, I mean, I think the Stack Overflow based engineers still true. And now
Basically,
people are just copy pasting from ChatGPT instead. It's all the same stuff.
that's true. It's all the same. The copy and pasting tools have just gotten a lot better.
Yeah. And now it even looks like your own.
Are you a big ChatGPT user?
I would say I'm a pretty mid ChatGPT user.
Mm,
Like there's some things that I look at it and like, this is so well suited to and it's perfect. And I'll get
right.
it to do a first draft. And I really like Copilot, GitHub's Copilot. I use that all the time. But I typically find as soon as you ask ChatGPT to do something a bit larger, it's not to the quality that I expect of myself. And so I'd need to end up rewriting so much of the structure that it's best in the small size.
For sure, for sure. I've recently been using a lot of like Aider and other programs that interface with either ChatGPT or now Claude, and
Yep.
those are pretty good.
Yeah.
And I guess we're going to talk about this a little bit later, but this guy, what's his name, Duncan from JITX, uh, did a huge article on using AI for circuits, and he found that Claude was basically killing it.
Yeah.
So Claude knows stuff.
I've seen its reasoning scores are pretty solid.
Yeah.
So makes
Yeah.
sense.
Very cool. Why don't we get in sort of to the first topic? And the first topic is what does it feel like to design electronics in the future? To tee this off, I think like when I romanticize electronics, what I think of is like Tony Stark in his lab, not in the cave, not that part, but in his lab, kind of talking to an AI and rapidly building new technology at a pace that's like ridiculous in sci-fi. But then when I look at it, I think some of this seems like it could be possible, just not with the tools we have today. Like you I can't imagine I can't imagine Tony Stark opening up like, Altium or Cadence and then dragging and
No.
dropping or like going into wizards for creating.
Let alone PowerPoint. Jeez.
Right, right. Um, so I can't imagine it, but I can see it with kind of like code. I can see AI generating the code that makes those things and then presenting kind of the output to him. And so I think there's a lot of potential in electronics as code to accelerate towards that future where you can just build stuff really, really fast. Um, Super curious what your take is on the future of electronics.
I mean, the Tony Stark in his workshop is what resonates, I think, for all of us, mate. It's not even just you and I, but I know it's true for Narayan and I think Duncan too, if I remember my conversation with him accurately. Look, it's in the future, we should be able to design a car in a handful of days, like
Mm,
a proper high quality production level car. And it's not actually, so it's weird because you think about why do we design things faster? Do we have more products? I don't really think so, but in the same way that you have a bunch of branches within a Git project, I think that's what it lets you do. It lets you
hmm.
explore more effectively so you can make better versions of the same thing or like go way, way deeper and try stuff that today your PM would turn around and say, like, you're bonkers. There's no way that we're doing a research project for six
Right.
months. We have to deliver something. But like 3D printing is already allowed for mechanical design, you bring that iterative cycle down to hours instead of days, or in that case, weeks. You're able to actually try, prove out things, and just do ludicrous stuff, which means we can basically make better things around us way faster.
Yeah, yeah, I can see that. So basically, like, if an engineer has a hunch,
Yep.
right? Like, what if we tried this different chip for our motor controller? That doesn't become a week-long project. That's just maybe it already exists. Maybe you can already see that alternative because somebody's like module switches it automatically or something like that. I don't know.
Yeah.
Like, I guess autopilot is electronics is code. So uh how does that fit together with building a car in a few days? Building a car in a few days is really impressive. That would be crazy. From it is the hardest part of a car the electronics or the mechanical design, I guess.
It depends on your car. It
Hmm,
depends what you're doing for
fair.
sure. But it's actually more of a conceptual thing. I think just what does it feel like to do this in a few days? And it's not just the electronics, it's all the hardware, of course, as you say.
Yeah.
But in software we have this like very lean mentality where you can kind of emulate a business in a huge way. And it's kind of dissolves as you go further and further into deeper and harder tech. As people are like, no, no, we actually need to physically build the prototypes and there's going to be a huge amount of money involved and whatnot. And I think that lean mentality in software I think it's been pretty productive. It's let people dream. And I think by bringing these tools to hardware, we're not going to see more cars. Like, who cares about the cars? We've got plenty of them. It's going to let people dream in the same way we do in software, but in the hardware space overall, basically.
Yeah.
Extrapolate there and really take the lean thing fully across.
I can see that. I think like, we had the humane pin
Yeah.
recently, and it's like there were a couple there's another one too. It's like rabbit.
Yeah. Have
Um
you tried it?
I have not tried it. Have you tried it?
Yeah, Narayan's got one.
Oh, no way.
Yeah,
How
yeah.
is it?
Yeah. It's pretty questionable. No. It's one of those items that you pick up and at first glance you're like, oh man, this thing's cool. And it's designed by teenage engineering. So like, of
Right.
course, it's so aesthetic. And the orange is just vibrant, it's beautiful. And then you like actually try use it. and it wasn't connected to the Wi-Fi despite saying it was. So I needed to
Oh,
reboot it,
interesting.
but it didn't actually indicate that. You press the button to talk to it, it just does nothing. The little rabbit bobs there, it listens, and then it ignores you. And so I can see the theory. I'm a little dubious, skeptical about doing it offline. But I think where you're going with that is like, well, what if instead of that project being hyped for 6 months and then see how it works? What if instead we just built the thing
Right.
and saw what it was like in the beginning?
Right. Like the thing with open source for software is if you release a bad version, you do have that kind of first to market advantage, but that advantage doesn't dominate the advantage of having a good product. Like alternatives will come up relatively quickly, and so you actually have to have pretty good products and software, or else people will just build a better alternative. Like, I mean, even for like Redis changed their licensing recently, and so like 3 Redis alternatives popped up, right?
Yep.
Like if you fail on one part of it, people can move quickly to do it. But you don't have that kind of mobility in hardware. There is a huge first to market advantage because the R&D costs are high.
Well, even beyond that, it's amazing. You talk about open source as it is the go-to, and you'd think in electronics that even open data sheets, like, hey, I want to go buy your chips. Obviously, they're going to give me the information about it, but it's not the case. If you go try buy a BMS chip from some of the really big manufacturers, you need to sign an NDA to actually get the data sheet to try use that chip and see
Oh,
what it's
interesting.
capable of,
Huh.
which is a weird one because I don't know, just take the example of like ADI and TI, for example. I'm sure they have each other's data sheets, and I'm sure they know that each other have each other's data sheets. So I'm actually not sure who they're trying to hide this from.
Yeah, that's a bit weird. I remember I should read up more on this, but Easy or Snap EDA, I think they have like some kind of alliance for open like hardware just because there was something like that where people were just not giving data sheets out. And it's like, who is this helping?
Yep.
Like you're not going to sell more products. But I guess they're a little bit at the well, I guess chip dynamics are just different. Like they might be really worried about even if everything is closed, somebody could try to duplicate it. So maybe that's why.
But I mean, even if it's closed, so like let's assume you can always get your hand on whatever documents particularly when you look overseas, like someone's going to get those documents.
Gotcha.
And I'm sure you could find a copy of them somewhere in the depths of the internet. Um, but if you want to reverse engineer the chip, you go, I mean, worst case, you go buy whatever device they're embedded in, you desolder it, you decap it, you x-ray it, and hey presto, you've got like physically got one. You know what it's capable of, at least to some large degree,
Right.
and roughly at least how they put it together. And it requires a lot of expertise to go further than that, but you can definitely reverse engineer stuff.
Yeah, that makes sense. Yeah. So yeah, you might as well just release it. So why don't they? What's going on?
I actually
What's in their
haven't got
head?
a good answer out of them yet. I've asked them, and I've asked them a few times, and I think this is the problem with playing, like talking in a chain. Because I'll talk to the sales reps and be like, "Hey guys, this is insane," and they're like, "We know it makes it hard to sell the chips. Let me go talk to Tech XYZ," and they sort of pass back, and they were like, "Someone said no. Sorry guys, still fighting for you. Can't do it." But on the point of the open source electronics, I think code to describe hardware is going to change this because it's going to change the mentality in the industry. When you have this vibrant ecosystem and value of sharing come up, then all of a sudden it's advantageous to come in. You don't want to be that one manufacturer that's sitting on their laurels, waiting for people to come to you when people are out there using something else instead.
Right, right, right. Yeah, that's really interesting. There was this thing that sometimes comes up when you create like a wrapper for something. Or like somebody might create like an autopile or a TS circuit or a JetX module that like kind of wraps a chip, right? And
Yeah.
it's kind of got all the specs of that chip built in. There's this phenomenon that happens where like if it's wrong, people might complain to the manufacturer. And I think that creates an incentive for the manufacturer to be like, okay, we're going to release the official ones.
Yeah.
And so that would be a really cool dynamic to happen. But it could be a little while before that happens. Do you see any progress on that anywhere?
Maybe a little bit. I would say that, like, as I mentioned, some of these big manufacturers been talking to, there's definitely some allies with them who are saying, like, your pitch totally makes sense. I want to open this up. And I mean, that's step one, right?
Step one is opening up. But is the problem that we have so many closed kind of data sheets, specs, or is the problem that the data sheets are kind of just PDFs that like an engineer actually has to look at, right?
Oh, I mean, they're both huge problems. And we're both trying to fix both of them. So
Right.
yeah. No, look, I think look, in terms of thinking about this future of like how do we design things, I think of it as in terms of like deterministic generative design.
Mhm.
Like you've got generative design where you sort of got like these boundary conditions and it'll randomly create something within it. And I think of the code to electronics as a deterministic sort of middle step there. That means if you recompile the same inputs, you get the same output, which means that all of a sudden it's testable, it's validatable, all that type of stuff.
I see. I see.
And so what that does to a huge degree is it reduces the burden on the engineers to create high quality products. And so you go with the most walked path.
Yeah.
You know, I see things going the way of kind of Netflix in their development culture, where they say you can do whatever you like. Here is the most walked path. And if you want to go off it, we expect you to hold everything to an extremely high quality.
Yep.
And so what we've seen with Adapile is that we have a reasonably high quality Raspberry Pi Pico implementation because it's great. We like it. It's cheap. Throw it in everything. And we basically chuck it on every board as like an on-board debugger
Mhm.
because like I want to see if this chip works. Okay, well, let's connect it up to the I2C bus and I can kind of just talk to it. And then if I don't want to, I just remove those solder bridges or something like that, depop those resistors, and I can go back to before. And what that actually means is that now the Raspberry Pi Pico has become practically a de facto standard for us and a bunch of our users to just slap on
Mm.
everything. And if you want to be part of that de facto standard, then come aboard. And if not, like the further we go, the further you are by the wayside,
Right.
because all of a sudden you don't have all this kind of almost social infrastructure behind all the
Right.
practice and how we design things.
Absolutely. Yeah, I think that happened with the ESP. Like ESP, I haven't used it in ESP yet. I just purchased some, so hopefully I get to play with. Have you played with the ESP at all?
Oh yeah, plenty enough.
Yeah, yeah,
Yeah, they're fantastic.
yeah. It seems like the ecosystem. Like I didn't know this, but you can literally use the Arduino toolset against an ESP.
I do.
Yeah, so you could just open up the Arduino IDE. I had no idea,
Yeah.
and they're doing that for a couple chips. But yeah, the ESP community seems like really robust.
They are extremely
Yeah.
robust, and they use them in production as well. On like, I mean, everything from the smart bulbs to motor controllers and things these days. It's look, granted, low production,
Right.
kind of mostly gimmicky products is like typically what
Mm.
I've seen it in.
Okay.
But still, I mean, that's a pretty simple de facto standard. And now, it's I typically like, sure, I was a firmware engineer, but I don't really like writing like robust firmware. I'll take Arduino any day of the week. And that's actually one of the biggest deciding factors when I design anything new that's not going into production. It's like, I need this to be easy. And so it's an ESP32, Raspberry Pi Pico, already mentioned, STM32, or the Nordic NRF52 series
Hmm.
all have Arduino support now. And I'm not that likely to touch anything that doesn't.
That makes sense. That makes sense. And do you use like the sort of the regular Arduino toolset? Like, are you opening up the Arduino IDE or VS Code?
Platformio, for sure.
Oh, platform. Oh, okay. Okay,
Yeah,
cool.
strong recommendation there too. It's fantastic.
Okay.
Yeah.
Super interesting. Hey, everyone. Thanks for listening to this first episode of electronics.dev. We forgot to record an outro, but if you're interested, please subscribe to our newsletter at electronics.dev, to our YouTube channel, our Twitter, etc. We're going to be talking about the future of electronics using code, using AI, and all the latest technology surrounding that on the cutting edge of innovation for electronics development. So if you're interested, go to electronics.dev, and thanks for listening.